Hi guys, Miss Norland here. Hey, we're skipping from lesson 18 to 21. So something kind of cool. There's special relationships within right triangles. So that's what this lesson is about. What we're going to be doing is, the title of the lesson is Special Relationships Within Right Triangles Dividing into Two Similar Triangles. So what's the objective for this lesson? Well, one thing I want you guys to understand is that the altitude of right triangles from the vertex of the right angle to the hypotenuse divides the triangles into two similar right triangles that are also similar to the original triangle. And hopefully we're going to do this with an index card. We're going to try to figure that out. If I can get all of you to get some index cards or some paper, we might do a little activity with that. But for right now, we're going to stick with the study guide and go from there. And then the other objective is I want you guys to be able to complete a table of ratios for corresponding sides of similar triangles that are a result of dividing a right triangle into two similar subtriangles. This is really going to set us up for figuring out our trigonometric ratios when we get into trigonometry. And that's our next unit. So this is all kind of just laying the foundation for that next unit for us. Okay, so we're going to use the diagram below to complete parts A through C. So a little review work should start feeling familiar. So we have two triangles here. And it says, are the triangles shown above similar? So let's just kind of grasp onto or try to recall what we know about similar triangles. So we do know all the angles are congruent, and we know side lengths are proportional. So we do know that. We don't have to know all the angles are congruent to one another, corresponding angles are congruent to one another. And we don't have to know all the side lengths are proportional. But what we do have some minimum amount of criteria we could use. So maybe we could use the angle. So look at the situation here. If I know two angles are congruent to two angles, well, let's see. I've got these are my right angles. These are two right triangles. So I got those congruent to each other, but here again, those do not equal, but I'm missing that third angle in each one. So maybe if I do a little math, that might help me out and I can see. So we've got angle, we could possibly use. There's side, but in this situation I don't have that. I'm missing a third side over here, and I'm actually missing two sides over here. So side is not gonna help me out, and then that means side is also not gonna help me out. So I have to kind of try to rely on that angle criterion. So let's fill in what we know. So if we have, because of the triangle sum theorem, if I know two angles in a triangle, I can find that third one. So what we're going to do is I'm just going to go ahead and subtract what I know from 180. So I'm going to start with 180 because I know that is the sum of all three angles in a triangle. And I'm going to subtract out that 90, and then I have 90 left, and then I'm going to go ahead and subtract out that 56.3. And what do I have left? I have 33.7. Well, that's great, because what we got here then is these two angles are congruent to one another. And that's all I need to know. I just need to know that two angles are congruent to two angles, okay? So that's awesome. So are the triangles below similar? I can now state yes. Yes, and that's because of the angle criterion. And what that states is that two angles of one triangle are congruent to two angles of another triangle, corresponding angles, then the triangles are similar. So what are the angles? Well, I have angle B is congruent to angle Y, and I have angle C is congruent to angle Z. So that's our proof. Okay. So determine the unknown lengths of the triangles. Okay, so once we know two triangles are similar, now we can use what we've learned about proportions to find, and scale factors, and to find any missing lengths. So if I want to find one of these lengths, so I have this one and I have this one, okay? So I have, let's think about corresponding sides. What corresponds? And I think it helps if I just grab out a highlighter here so we know what corresponds. So my 90 and between my 90 and my 37 are these two. Those correspond, right? All right, and we know that if we were to do the math, we know this is 56.3. And so between my 90 and my 56.3, these correspond, and they're oriented the same way, so this isn't really hard to visualize. You can see the correspondence, but I'll go ahead and mark them up for you guys. Okay, so let's think about it. So I have this AB, which is 2, and I have this BC, which is 3. I have XY, which corresponds with the 2, and I don't have this. So maybe we can find this length. So let's see what we can do to find this length. So let's just call this, I have an X right there, so let's just use a variable. I don't know. How about M? Why not? Okay, so let's go for it. So I can say, I can use within ratio and go 2:3 as 1.5 is to M, cross multiply, 2M equals 4.5, I divide, M equals 2.25. Okay, does that seem reasonable that this would equal 2.25? And I think it does. When I look at the situation, I think that seems reasonable. Now, question, is there any way to find the third side? Are we able to find that? Well, not really with what we've been working on, but if we go back into 8th grade, do you guys remember the Pythagorean formula? So, if you recall, a squared plus b squared equals c squared, because we have right triangles here, right? And if you know two sides of a right triangle, you can always find the third side by substituting the values into your Pythagorean formula. Now c is always your hypotenuse, remember? And that's actually what we're missing here. In each triangle, we're missing the hypotenuse, okay? So maybe I try this one here. So 2 squared plus 3 squared equals c squared. 2 squared is 4, 3 squared is 9. Add those together, I have 13 equals c squared. So that means c equals the square root of 13. Now 13 is a prime number, so there's no way I can simplify that. So I either have to leave it in radical, so rad 13, or I can use my calculator here, and we're gonna have to round in this situation, so we're not gonna have a nice number. But I go to second, and then I go to this little caret, and I put in 13. And so, see what I mean? We'd have to round. So maybe I do 1.08. That would get us pretty darn close. So we have about 1.08, okay? All right, well I could do the same thing with this one, or I can set it up to a proportion, okay? So it wouldn't matter. So if I were to do this one, I'll just slide this over. So a squared plus b squared equals c squared. So we can make either one of our legs a or b. It does not matter. So 1.5 squared plus 2.25 squared equals c squared. So what is 1.5 times 1.5, or 1.5 squared? We get 2.25. And what is 2.25 times 2.25? Well, that is 5.0625. Add those together, and we're going to get 7.3125 equals c squared. And you know the drill here, so we have to take the square root to find out what c is. So if I take the square root of that number, it's not a very nice number, right? We're gonna see. So the square root of 7.3125 is not a very nice number. So should we go with just 2.7, about 2.7, so about 2.7. Now realize that the hypotenuse is the longest side, so some of our math is not working here. I'm going to go back to the square root of 13. I did something wrong there. I did something wrong, because I just thought about that. That does not seem reasonable at all, because our hypotenuse should always be the largest side. That looks better. So let's do 3.6. How about that? Okay, go back. I just started looking at that thinking, I must have hit the wrong button on the calculator. Okay, because this should be our longest side, and that checks. And this should be our longest side, and that checks. Okay, so that's one way. We can use similarity, set up proportions, we can use our Pythagorean formula. So we're gonna have a lot of ways that we're gonna be able to solve for triangles, for the side lengths of right triangles. So I'm going to turn the video off now, and I'm going to move on to the next part of it. So be ready for that in our next video.